welcome to the Hedera workshop for today. This is the agenda. So we've already done the first bit, and now we're going to start with the with Hedera TLDR. You've also just heard from Jordan as well. So thanks for that. And yeah, I'll just get started. So this is me. A little bit about myself. So I'm Brendan. I'm a DevRel engineer at Hedera. Prior to that, I was at Rootstock and at dApps Dev Club. For those of you who were around in 2019, that was one of the first tech-focused meetups on building on Web3 in Singapore. And going even further back, I was a Web2 software engineer for quite a while. And here's my YouTube channel where I cover DevRel strategy, day-to-day DevRel tasks, as well as the video outputs of my DevRel work. So I'll leave this up on the screen for those of you who want to scan it. Right? And then this is me on Twitter, BGUIZ, if you want to follow me, get updates, etc. So let's begin. Right, so Web3, you've probably heard of it, but what is it really? The technical answer centers around blockchain-based applications, but let's look at it through the lens of use cases, specifically how we use information. Before any sort of web, we handled info using paper records. Then the internet was invented, and you basically got unidirectional information from large companies with large computers that would literally fill multiple rooms. Then XML HTTP request was invented, which allowed web pages to become interactive, and thus web apps were born. And most recently, blockchains with smart contracts were invented, and that allowed web apps to be decentralized. So the stages of innovation that I've just gone through correspond to Web 1, Web 2, and Web 3. Another way to think about these stages is the implications for the people who are using the internet. So Chris Dixon named this paradigm. So in Web 1, you could read information. In Web 2, you could read and write information. In Web 3, you could read, write, and own information. Information ownership without any company or government able to gatekeep or disable or confiscate or censor, that simply wasn't possible prior. So this is what makes things like stable coins, NFTs, that sort of thing possible. However, for Web3 to work, as I've just described, right, the read, write, own paradigm, you need the technology to actually support it, right? And that underlying technology needs to do these things, right? So it needs to replace it needs to replace authority with cryptography, centralized control with decentralized control, and proxy ownership with real ownership. So those seem like really lofty goals, and it was actually quite a difficult riddle. And Bitcoin finally solved this by inventing something called a blockchain. This was a ledger of transactions that could only be added to, and it could never be deleted or modified. And those new transactions could only be added if the participants agreed to it on consensus. So anyone with an internet connection and a computer can process these transactions, and all of this was achieved by marrying cryptography together with peer-to-peer technology in a novel way. Right. So peer-to-peer technology was primarily used for file sharing prior to this, and now I'd say blockchain is like the biggest use case of peer-to-peer technology. But all of that, like Bitcoin, came out over a decade ago. Right. Bitcoin was limited, and it could only realistically achieve one thing, right? One use case, which was to transfer units of its own cryptocurrency, which was also called Bitcoin. So Bitcoin, the blockchain, Bitcoin's also the cryptocurrency, and that's all it did. So that didn't really quite unlock the read, write, own part of it, right? It was more of a single purpose use case, right? Then came along Ethereum, and it did the same thing as Bitcoin, the same fundamentals, exactly the same, but it added something new, right? That was the ability to deploy and execute arbitrary programs on the blockchain. So any developer could write their own program and put it on the blockchain, and that program would be subject to the same fundamentals that Bitcoin transactions were subject to, and that was novel, right? That made it general purpose, and these programs were called smart contracts, right? So now it's finally general purpose, and this enabled decentralized applications, also called DApps, and that was what really triggered the change from read and write to read write only. That was, the existence of Web3 got sparked into existence. So now we're at the third generation of blockchain, so we move past that. The problem with the first and second generations, like for example Bitcoin and Ethereum, is their speed or their performance. So right now, right, we are used to using instant messaging, for example, WhatsApp or Telegram. Now, would you go back to using physical letters with envelopes, right? Would you actually do that? We're also used to using mobile phones, right? Would you go back to using landline phones? And just curious, how many of you here are old enough to remember using the internet over landlines? All right, see a couple of hands, right? Well, what was that?
Yes, I'm old.
Yeah. Okay, so it turns out that that is exactly what the early Web3 adopters were faced with, right? So they went from interacting with Web2 applications, which would respond in milliseconds, right, to Web3 applications, which would respond in tens of seconds, sometimes even minutes. And that's clearly a big enough of a usability problem, and that would actually inhibit the mass adoption of Web3, right? So your average user basically is not going to transition from a Web2 user to a Web3 user for this reason, among others, right? So Bitcoin's first generation, Ethereum is second generation. What is the third generation? What solves that? What solves this problem? And Hedera is among one of the blockchains that has solved this problem, right? And in my opinion, it is the most outstanding representative of it. So the throughput goes from roughly 10 to 10,000 transactions per second. The latency, which is lag time, goes down from 15 seconds to 5 seconds. And the cost per transaction goes down too as well, from being measured in dollars to being measured in fractions of a cent. So most other third generation blockchains have also achieved some level of scalability and performance improvements, but the way that they have done it is by becoming a layer 2 network. And one of you was asking me this earlier on before we started, right? Is Hedera built on top of Ethereum, right? And no, it's not, right? It's not a layer 2 network on Ethereum. It's its own layer 1 network that happens to be EVM compatible. So most other blockchains that have achieved this scalability statistics, right, or performance traits, they have done so by piggybacking off of Ethereum as a layer 1 network, right? So the consensus, which is the expensive part that causes the biggest performance penalty, that happens in Ethereum, and then your layer 2 network sort of just says, okay, the difficult work is done. I'm just gonna, build on top of that, right? Hedera has taken a fundamentally different approach, right? It's innovated on the underlying technology of the blockchain itself on how to achieve consensus. So instead of using a data structure, which is like a linked list, it uses something else called a graph instead, right? And I would say that this is similar to a single lane road, going from a single lane road to a multi-lane road. So that graph in Hedera, that data structure, is called hash graph. And it means that instead of processing just one transaction at a time, which is what happens on a blockchain, in serial, you can do them in parallel, right? So you can process multiple transactions at the same time, simultaneously. It also does away with blocks before or during consensus. So think about this. It's like a blockchain, but it doesn't have blocks during consensus, right? Which is very different. So instead, what it does is it still builds the blocks, but the blocks are built after achieving consensus. It's quite different in that front as well. So that means that transactions get added deterministically as well. So recall that single lane versus multi-lane analogy from earlier. Well, this is what it looks like when it's been diagrammed. So given that the underlying data structure is so radically different, we've gone from the linked list of blocks to like a graph of individual transactions. So when you see this, right, is Hedera still a blockchain? And the answer to that is yes, because what it does is to reassemble these transactions that you see, individual transactions, into blocks, but it does so post-consensus, so after consensus is achieved, into a structure that resembles a blockchain. So the output of a hash graph ends up being a blockchain. Now, if you'd like to dig deeper into what I've just described, you can read one of my blog articles. I've got the QR code up on the screen if you want to scan it, right? So this is blockchain or not, and it refers to, whether Hedera is one. So let's go on. So let's see. So what does hash graph consensus actually do? So it does validation of transactions, which is something that every blockchain does. It also fairly orders the transactions, which is something that surprisingly most blockchains are incapable of. They're able to fairly order blocks, but not the transactions within them. And that's the primary reason why you've got such a thing as MEV attack vectors, right? Hedera doesn't have them because it orders transactions rather than blocks. Hedera also uses cryptography for transaction signatures, and that's something that all blockchains use, including Hedera. And the final two items are actually unique to Hedera, right? They're gossip about gossip and virtual voting. And these are unique to the hash graph consensus algorithm, and they are a core reason for Hedera being so efficient and fast. But how do these work? That's beyond the scope of this talk, and I'm not really going to explain it. Instead, you can watch this video on YouTube, QR codes on the screen. It's by Dr. Lehman Baird, who invented Hashgraph and started Hedera and still runs it today. And he's obviously going to do a much better job of it than I ever could, so please do watch that later on. Now, let's switch tracks a little and get technical, right? So if you're a developer who happens to already know how to work with other blockchains and how hard it is to learn, so how hard is it going to be for you to learn how to build on Hedera? So the answer is not really that difficult at all. So if you are familiar with EVM development, so if you're a Web3 developer, you'll probably already know JSON RPC, so you can communicate with Hedera in that way. If you're familiar with Web2 development, right, our mirror node APIs are going to be quite quick to pick up because those are similar to most Web2 APIs. The only thing that's likely going to be difficult are the raw Hedera APIs. And here are some examples of a JSON RPC request and a mirror node request. So if you've ever done like curl requests before on the command line, it looks pretty similar. Now, recall the raw Hedera APIs, which I mentioned earlier on, that were difficult to learn. Well, the good news is that we have SDKs that wrap around those, and it makes it much more accessible for Web2 developers because they're available in JavaScript, Java, Go, and several other languages, right? This list is out of date. So one of you earlier on was asking me as well, like, I don't know Solidity, right? I haven't learned it yet, but I know this language, right? Can I build an Hedera? Absolutely you can. And in fact, the workshop that will happen after this, that's precisely what we'll do, right? So we've actually received feedback from many Web2 developers on, like, they were pleasantly surprised that they could be productive building on Hedera without learning a new programming language. They didn't have to learn Solidity. And likewise for Web3 developers who are already familiar with Solidity and other, Web3 developer tools, they were also pleasantly surprised that even though Hedera is not an EVM, so I should say not a Ethereum layer 2, it is EVM compatible, and they're able to use the same Web3 developer tools and workflows, and they just work out of the box on Hedera. So Hedera has multiple services, and you see them on the screen here. The one that Hedera offers that other blockchains also offer, for the most part, is its smart contract service. So the offering here is virtually identical to any other EVM compatible blockchain, and that's a good thing for the reasons I just mentioned earlier on. In addition to the smart contract service, we've also got a token service and a consensus service, right? So the token service allows you to create a fungible and non-fungible tokens without any smart contracts. So you simply use the SDK directly and you can create your own token and interact with it. And it also has a consensus service which allows you to operate a message queue similar to SQS or Kafka, so pub-sub type message queues. So here we see Hashcan, which is a network explorer, and it shows EVM compatible smart contracts on Hedera. Now, note that Hedera tracks the latest version of EVM very closely because it incorporates the implementation of the EVM used in Hyperledger Base Loop. And this over here shows the native tokens on Hedera. Note that even though they do not use smart contracts, they are fully compatible with the ERC20 and ERC721 token standard APIs. This shows a pub/sub message queue on Hedera, and you can register topics, add messages to them, and subscribe to a topic to receive any new messages. Okay, let's change gears once more and move on to governance. So Hedera is cutting-edge technology, and it is important to keep up with the pace of development and to have a structured way in which to do so. Hedera uses Hedera Improvement Proposals, or HIPs for short, to manage the process of taking an idea for a new feature for the network all the way through to implementation. If you are familiar with the EIPs and EIP processes, this is fundamentally the same concept. Hedera also has a governing council who votes on decisions to do with its product roadmap, for example, the HIPs, also on treasury, etc. Each of these governing council members also runs a Hedera node, and when they have meetings, they notarize them on Hedera Consensus Service. All right, so that's all for this talk, and here's a recap. We walked through the evolutionary steps of Web 1, Web 2, and Web 3, and how that relates to the read, write, and own paradigm. We also talked about the evolution of blockchains through the three generations, and how Hedera solves the performance issues of the second generation through its own unique consensus mechanism called Hashgraph. Next, we covered how easy it is to learn how to develop in Hedera, and we also mentioned the different services that Hedera offers, and wrapped up with the governance model. And that's a wrap. Any questions? Anyone? Okay. Jessalyn.
Good evening, everyone. I'll just do a quick introduction of myself. And the reason why I get this airtime, this 1-2 minutes airtime, is because you guys are in our Aspire office. So we're sponsoring the venue for this event today. And we're really thankful to be able to partner with Jordan from Tenity, with Brendan from Hedera, and with APEC now as well. So we are all closely related. And then what we do is provide an all-in-one finance management solution. I'll stand right here. So a bit of introduction about us. We touched the fiat portion, but we are able to serve Web3 projects as well. So if, let's say, and whenever you decide to incorporate your company, set up your company, your entities, or if you have other side hustles that are incorporated in Singapore and the rest of the world as well, then think of us. So we are an all-in-one finance operating system, and we were established back in 2018. To date, we have actually close to 20,000 plus active users, active businesses on Aspire as well. And what actually we do is provide this global multi-currency account for Web3 businesses. So I think the pain point that a lot of Web3 projects tell us is that they cannot open a traditional business account. Because, you know, if you're related to Web3, you have keywords like blockchain and the likes, then a lot of traditional business accounts for fiat transactions then block you, and then you just can't open a business account. So that's what we are here to do. We have our own compliance team, our own KYC, KYB teams as well, so that's definitely taken care of. And then we are able to help with the fiat in terms of improving your liquidity. So for example, if you have to off-ramp your funds from crypto, from USDC, for example, or USDT into USD, and then you need somewhere to store that funds, right? To be able to make payments, salary payments, lease payments, and the likes, where only traditional currencies are allowed. Then that's where we come in. Our account is completely online as well. So what this means is that you don't have to fly all the way down if you're not based in Singapore. And you don't have to come all the way to our office, because if you notice, this office is just for us workers to work. It's not so much for an application opening. So all that is done completely online as well. And if, let's say, you have a lot of FX transactions, but it's not big enough, right, where banks roll out red carpets for you, that's where we come in to help you save some money on those transactions as well. And then everything else is integrated into accounting solutions like Xero or NetSuite. So that's all I have to share today. Thank you so much for lending me your ear. Any questions? Just let me know after this. Oh, yeah, sure. So we don't do the off-ramp ourselves. So we only charge the fiat portion, but we work with Singapore regulated exchanges. For example, Independent Reserve, Sparrow, CoinHarko, the ones that are have the license in Singapore. So the off-ramp fees will be charged by them. We only charge about a 0.1% to be able to transfer the funds in.
You do off-ramp, on-ramp, and off-ramp?
We don't do the on and off ramping. So the the crypto exchanges are the ones that do the on and off ramping. We are the ones that can accept fiat from all these exchanges where regular banks cannot. Yeah. So we touched the fiat portion of it, but we're in this scene because a lot of Web3 projects just cannot open a fiat account with traditional banks. So that's where we come in. Thank you very much. So I'll leave you into Brendan's good hands then.
All right, thanks once again to Aspire for providing this excellent venue. And so I hope all of you are ready for a hands-on workshop next.